Welcome everyone to another Tech 90. Today I got myself, Greg Bruns, and JD is with me. JD, say hi to the crowd.
Hello, everybody. Thank you for attending.
So today we're going to be covering the FLEXX R32 installation and airflow. Our schedule today, first we'll run a clip from a recent training covering refrigerant flow, wiring configurations, control options for both 24 volt and using the GREE controller, which uses RS485. Dip switch settings for whether you're doing a 24 volt operation or you're doing RS485 operation. You do have to set the machine up to know what control you're using. So we're going to cover that. We're going to cover dip switch settings for airflow if you're using 24 volt. If you're using the GREE controller and it's using RS485, it becomes variable speed at that point. You don't have to set the dip switches for airflow. We're going to talk about static pressure measurement, troubleshooting procedures for contractors, and verifying the airflow after we got our airflow set up. After that, we'll come back and chat with you live and answer any questions up to that point. So don't forget that ask a question button on the right-hand side of your screen. Then we'll continue with another training and cover dip switch adjustments again, a little deeper for airflow and stuff, static pressure demonstrations, blower speed behavior, refrigerant leak detection, zoning considerations. So there was a question that came from our previous broadcast about zoning. So hopefully that'll kind of give you some insight about doing zoning with inverter-driven systems. A little bit on inverter board servicing. And finally, we will finish up with another live Q&A session. We encourage you to get in the conversation. You should be the pros at this by now. As a reminder, if you have questions or comments at any time during this broadcast, use the question mark icon to the right of your screen and send them our way. We'll answer any relevant questions until we run out of time. So let's keep the questions, just for the audience, keep the questions pertaining to R32 Flex. These are short broadcasts that we do, so we really can't get in deep into job-specific questions. If you have job-specific questions, by all means, give our tech department a call. That phone number is 888-850-7928. Again, I'll give that to you one more time. That's 888-850-7928. And then just make sure you leave a voicemail, and as quick as we got an available tech to be able to give you a call back, we will give you a call back. That puts you on our computer screen for a call back. So, JD, anything you want to add before we get rolling with the first video?
No, just when you do call in, be sure to please leave a detailed message with model, serial number, and reason you're calling in.
Man, that's cute. I'm glad you said that because, guys, I say this all the time. We support so many different units, and I know you guys don't really always realize that. GREE's been around for a bit now, so we don't know if you're working on a 5-year-old GREE unit, whether you're working on a mini split, a multi-zone mini split, a flex unit, whether you got a commercial unit, a VRF, or a multi-pro single phase mini VRF. I mean, the list goes on and on of the equipment that we support. So if you just give us a model and serial number, that helps us tremendously. So when we call back, we can be ready for you.
Yeah.
So it not only saves you time, it saves us time, and we can get your resolution to your problem even quicker. So always provide model and serial number. And what I tell guys all the time is, when you leave the voicemail, leave the model and serial number of the outdoor unit, but be prepared with pictures of the data tags of the outdoor unit and the indoor units. Then that way, because once you leave that message, you're going to get a text message back, and all you got to do is reply back with the text messages of those photos showing the model and serial number tags of the indoor units. That way, we get the whole engine, transmission, and rear end all in one call, right? So now we know exactly what you're working on for the whole piece of equipment. So go ahead, JD. You were going to say something?
I was going to say, good point. And then we can make sure it's a matching system as well. That, sometimes we get calls and it's not even a matching system. That's why it's not working. And they only give us one piece of the equipment.
JD, it's interesting you bring that up because I've been doing tech support for a very long time, and I went down that rabbit hole before where I'm doing a bunch of troubleshooting with a contractor. Come to find out later on, the indoor and outdoor equipment didn't even belong together, and that's why we're having so many problems.
Yep.
So if we can kill that bird right off the bat, you know, it's just so much faster for you guys. And I mean, we don't want to have to tell you that, but I'm also a firm believer in it. It is what it is, you know. So at least you know what the problem is, and now you know what you're going to have to do to get it corrected. So,
Yep.
All right. So with that, let's get started. We're going to go ahead and roll that first video, and we'll come back to your live Q&A questions. So don't forget, ask those questions. Welcome, everyone, to another Tech Talk. My name is Greg Bruntz. I am the Technical Support Specialist for Commercial Product with GREE. And along with me, I got James, or JD here, sorry.
Yeah, I'm JD McCarty, lead trainer.
And?
Technical support.
Yeah, there you go. Yeah, you don't get away from that role yet.
Nope, still a big part of the technical support role. So I'll be on the phones too.
Well, and I think, you know, some of that, you know, doing the technical trainings, JD, dealing with the phone calls and what the contractor's going through out in the field helps us realize what we need to do.
What we need to focus on.
Technical videos about and stuff like that to try to help you guys out. So as I've mentioned many times before, these training broadcasts are for you guys. They're not for us. They're for you guys to be able to know what to do when you get out to the field to install, service, and work on GREE equipment. So,
right.
So just to kind of give you an idea what we're up against today, what we're going to be bringing to you. It wasn't very long ago. I don't remember exact dates. I'm horrible with dates. Daniel and I broadcasted the R32 equipment installation video with the new R32 FLEXX unit. So there was a lot of good questions that came up in that broadcast. So we did get some answers from GREE. I didn't get all the answers yet. But one of the things that Daniel and I, you know, because this is the first time we'd ever seen it, was when we come down here and installed it, right? So we come down and we installed it, and then literally the next day we're doing a broadcast about it. So we were limited with our knowledge as well, okay? So we pulled up the service manual and stuff like that. Well, right off the bat, one of the things I noticed was the piping diagram for refrigerant flow didn't show all the components in the unit. So I do have proper piping diagrams today, which we will be sharing with you, which we can kind of cover the refrigerant flow both in heating mode and cooling mode. We can also cover how they're doing low ambient control in the new FLEXX, because it is different than the way they were doing it when the 410A FLEXX. I think it's actually kind of cool the way we're doing this. We actually got rid of that gas liquid receiver tank that was in the 410A equipment. So when I bring up those piping diagrams to share with you guys, I've also got in there, you know, so we can get to them quickly, the piping diagrams from the previous gen, the 410A unit. So you can see the difference between the two. So I think that's going to be beneficial to a lot of guys. They're like, oh, okay, here's where we were, here's where we're going, right? So I think that's going to be kind of interesting. I found it interesting, so I think everybody else will enjoy it too. A little bit more detail about setting the system up for 24 volt versus using the GREE controller. We're going to talk a lot about that. We've got the wiring diagrams for both 24 volt and RS485, which is what their GREE controller does. Factory, it comes shipped with the GREE controller setup for the dip switches. So if you're going to be using 24 volt, it's very important that you know how to set the dip switches so that you can get the thing to work in
either 24
volt operation.
Yep.
Because, and I say this because our first shipment coming to us, and the first R32 FLEXX units being sold, I'm going to tell you guys right now, the controller was not included. So when you first get one of these, and we're working on getting controllers, as far as the last I checked, we don't have them yet. we're going to be getting GREE controllers if you want to use the GREE controllers. So I don't want you to feel like if you buy a system today and you go install it, you're going to be installing a system you can't make it run. To use a 24-volt thermostat if you're wanting to use the GREE controller. There's advantages to using the GREE controller and disadvantages. So it depends on how you look at it. It's not what I look at, it's what you look at, right? So what I'm saying is the advantage is you're not going to have to set dip switches for blower operation, and you're going to get more of a variable speed with the GREE controller. If you use 24 volt, now you're going to have to set the dip switches in order to get proper airflow for 2-ton, 3-ton, 4-ton, and 5-ton. Okay?
It becomes a fixed DCM at that time.
So there's the advantage with the GREE controller. You get more of a variable operation with the system. The disadvantage, and some people, I don't want to say disadvantage, some people would view it as a disadvantage. If you want Wi-Fi, you're going to have to use GREE's Wi-Fi if you're using GREE's controller. It is Wi-Fi capable. You got to use GREE's Wi-Fi. Some people like it, some people don't. Again, that's why I said it depends on how you, when I say advantages and disadvantages, it's how you view the disadvantages and advantages, right? Or the homeowner views the disadvantages and advantages, or end user, because I mean, I guess you could use this equipment in a commercial product or commercial installations as well.
Right.
So some people are like, oh no, I got to have my Ecobee because I really like their Wi-Fi. Well, that's great, okay? So that's the beauty of the system. You can use both. You can do 24 volt or you can use GREE controller. So you got options. I like the fact that you got options. So we're going to talk more in depth about how you set the thing up for 24 volt, how you make sure it's set up properly for the GREE wired controller. We're going to go over the wiring diagrams for those. We're going to go over blower dip switch settings for selecting the speeds if you are using 24 volt. And we're also going to cover, there's a jumper that has to be applied, and we'll see that in the wiring diagram if you're using the GREE controller, if you're using backup electric heat. If you're not using backup electric heat, it isn't going to matter, okay? Am I forgetting anything?
I think you pretty well covered it, yeah.
So it doesn't sound like a lot, but it actually is a lot when we get to talking about it. So with that, we're going to jump right into our slideshow here and talk to you about some of the piping diagrams and stuff like that. So let's move forward with that. This shows the line voltage coming in. If you don't have a heat kit, you're just going to wire nut to a little pigtail right here, and I can show you that on that air handler when we get over there. And then you're going to have your connection that plugs up the board to the heater kit. So as far as the RS-485, it's pretty simple as far as the wiring. You do have to run R and C to the controller in here. There's also a W2 auxiliary on the thermostat. I think the diagram is a little deceiving in that they're telling you got to run a wire from W2 to auxiliary, and you also got to put a jumper from R to W2. Well, if you think about it at all, that really doesn't make any sense. So if you jump R to W2 right here, or jump R to W2 either at the controller or the air handler, you're accomplishing the same thing. You don't have to have that wire running across there. And then you got to have R and C going outside, and then you got to have your H1 and H2 from the indoor unit to the controller, and you also have to have H1, H2 from the outdoor unit to the indoor unit. Now, it's pretty simple to do, and I can show you again at the air handler. They actually give you multiple connections, so it's real easy to make your connections from the outdoor unit. You're going to have a set of separate screws that you can screw on to get on the H1 and H2 here. Then you got another separate set of screws for H1 and H2 that'll allow you to hook up the controller. So it makes it really convenient. You don't need a bunch of wire nuts and stuff like that. So it's not hard to do at all. So, all right, moving on to the 24 volt. Now, this is showing the wired controller and the temperature controller. I guess you could do that where you could have the wired controller hooked up
and the regular thermostat. More of that will be answered in the instructions that come with the controller, because we have not gotten any of the controllers in yet, so I don't have the instruction manual just yet, and we're waiting on GREE to get us that information to where you can have, like I said, there may be advantages to having the wired controller hooked up and a 24-volt thermostat, because there may be advantages as to what we can do with this controller once we get the manual. And you can actually, this is going to be, I would think it's going to end up being very similar like multi-pro. So you'd have one as your master controller, sensing room temperature, controlling the operation of the unit, and the other one would be like a slave, which in this case, I would think the wired controller would be like a slave. This would be the one to be in your room sensing temperature and stuff. So more to that in future broadcasts. Also, if you look at the instruction manuals, once we have them, you'll know more about that. But what I wanted to make sure you understood was H1 and H2 from the indoor to the outdoor, or even whether you got a controller or not, you do not have to have the H1 and H2 between the outdoor and indoor unit. We tested that here in the lab. We set it up for strictly 24-volt operation, and there was no issues with the unit functioning for which is the 24-volt thermostat. You will notice in here, in the wiring, there is a Y that comes from the controller to Y on the indoor unit, and then from Y1, it goes out from there to the outdoor unit on Y. What that is for is because this is R32 and it has the A2L alarm in it, if this thing goes into alarm on the indoor unit because of the leak, it is going to break the 24 volts and drop it to the outdoor unit and shut that unit off immediately. The other thing it's going to do is power L. So your L would be powered to the outdoor unit, and that's where it gives you the air code is on the outdoor unit. Now, depending on what thermostat you use, you also see this L terminal going from there to the temperature controller. Be very careful, because some thermostats, if they have an L terminal, some thermostats that's an output, sometimes it's a 24-volt input. You need to make sure it is a 24-volt input, because we're going to send 24 volts out on L if it's an alarm. So if you have a thermostat that's trying to put out 24 volts, that doesn't work, and you could end up damaging either board in the air handler or the thermostat itself. So be very careful in how you do that, okay? So if you're not sure, I would just tell you don't hook it up. When it goes into alarm, the code will be shown on the outdoor unit. You will also hear the audible alarm on the indoor unit. Additional charge information. I just wanted to clarify this. This is in the owner's manual / installation instructions, but I was kind of looking through this myself. So the 2 and 3 ton has the factory charge of 88.2 ounces. Well, the unit is smaller, obviously, than the 4 and 5 ton. So it's not going to hold as much refrigerant. But I think that also is playing a role in our total charge. So this says your charge is good for 25 feet of refrigerant line. Additional charge after the 25 feet, you're going to use 0.323 per foot, ounces per foot. I'm sorry I didn't put ounces per foot, but it's ounces per foot. 4 and 5 ton, a lot more charge in that unit. We've got 162.03 ounces. And the additional charge is 0.215 ounces per foot. So, and I think that has a lot to do with it too, is because that outdoor unit has a lot more charge in it. That's why they've got a little bit less amount per foot. So I've actually verified that with the factory, and those additional charge amounts are correct. Moving on to refrigerant flow, okay? The piping diagram that they have in the service manual. It's wrong. I'm going to get it updated, but they didn't show the plate type heat exchanger. So as you can see right here in this diagram, it does show the plate type heat exchanger. So just so you know, this came to us from GREE. It was all black and white. I just went in and highlighted it to make it a little easier to read with the colors and stuff, okay? So, and I've always done this, and I'll do it again the same way. When you follow the flow, you follow it from the compressor. So you got your discharge gas coming off. We go into our reversing valve. Obviously, we're in cooling mode. We're discharging to our outdoor unit, releasing the heat, condensing into a liquid. Then we are going around the EEV outside. I think it's actually going through both. I would tell you this because this EEV is going to go wide open when it's in cooling mode. So I think you actually got liquid refrigerant flowing through there both, but I just kind of did the diagram, highlighted it that way to show you that's what's going on. And then this main refrigerant cooler, so if you look when we get to the equipment, which we're going to get to shortly, when you get to that equipment, you're going to see the board in the front where it's got the liquid line that's going all across an aluminum channel across the front of that board. That's what's cooling the inverter driver. It's not an air-cooled inverter driver. So that's what they mean by here by main board refrigerant cooler. Then it goes into the plate heat exchanger, depending on conditions of the unit. So it depends on whether or not the subcooler is actually being used. And all of that is going to be just like I've talked about in other broadcasts. It's going to be based off of what the pressure transducers are picking up, and that information as far as the pressure is being sent back to the main board, along with your outdoor coil temperature, your indoor coil temperature. When you're using RS-485, if you look at this new controller, it does have a indoor coil temperature sensor on it, so it can see that information. It's more limited in what it can see when it's in 24-volt operation. That's why we get better flow and better control and more variable speed if you're using the GREE controller. So, but anyway, what I'm saying is it's not always going to be using the second level EEV and actually subcooling that liquid refrigerant unless parameters of running dictates it to, okay? And GREE is not going to give you every scenario as to when they're subcooling, when they're not subcooling, and stuff like that, okay? So then our liquid refrigerant goes to our indoor EEV, because we're our EXV, whatever you want to call it. We got away from that with the 410A. So 410A, this was a TXV. Now it's an indoor EXV. Meter in our refrigerant indoor coil, we're flashing off, absorbing heat into it. Our cool suction gas comes back, goes through our reversing valve into our permanent suction port right here, through our, they call it a vapor separator. It's the same thing as an accumulator. Then out of the accumulator, you got the low pressure switch, and into another accumulator that's attached to the compressor. So that's kind of, in a nutshell, that's your cooling mode operation. So when we go into heating mode, again, we'll follow our flow again from discharge gas through our reversing valve. We're discharging in the top of our reversing valve. We're coming out the left pipe here, discharging into our outdoor coil, our indoor coil, sorry, because we're in heating mode, releasing heat inside. And then we're not metering refrigerant here, so this EEV is going to be wide open, liquid flow back. Now again, there could be times where we'd actually subcool this refrigerant some, and this would also be used for low ambient heating. So if we take liquid refrigerant and meter it through here into this plate type heat exchanger and absorb heat out of this liquid line, we're actually dumping that back into the compressor so that we can take the heat that we didn't release on the indoor coil pull some of that out of that liquid temperature and actually put it back in the compressor and compress it again for low ambient heating, okay? It's quite different than from what they were doing with the 410A version of the FLEXX. So, and we'll kind of go back to that in just a second. Again, our liquid refrigerant's going to our main board to cool the main board, and I can show you that as well. And then we go through our primary EEV outside now, which is our first level EEV. The outdoor EEV is actually metering the refrigerant, and this check valve's closed, so we're forcing all the refrigerant to meter through the EEV, flashing the refrigerant into the outdoor coil. We absorb heat from the outdoor air, boil that refrigerant off. Now we got a cool refrigerant gas coming back, going into the right side of the EEV, into our permanent suction, into our vapor separator or accumulator, however you want to look at it, and our cool refrigerant gas back to the compressor. So, pretty basic operation. Again, so now what I want to do is share with you the differences here. So if this is cooling mode, let me go to heating mode. And this is just normal heating mode operation. But if this was in low ambient heating, this gas liquid separator, your liquid's going to be down here on the bottom, so you're not affecting your liquid flow of refrigerant, right? At the top of here is going to be warm refrigerant gas, right? So they pull off of the top of that during low ambient heating. They open the electromatic valve and they dump it back into the compressor, compress it again. So, and now this valve, I've said this before, it depends on how cold, all the other conditions from the thermistors, all the data that the outdoor board receives as to how long and at what temperatures that electromatic valve is actually opening. So this is that gas liquid separator that I was talking about that we got rid of going to the R32 equipment. Because as you can see, you see the gas liquid separator there. When I go back here, you no longer have that anymore. We don't have an electromatic valve, but we do have the EEV for the plate heat exchanger, and that's where they're getting low ambient operation from. So I kind of like it because we get rid of this big cylinder in here that we don't necessarily have to have, which actually makes things a little better. So now what we're going to do is we're going to move to the equipment and less to, pictorial, and we'll come back to the owner's manual / installation instructions as well. So we're going to go right into how we set this thing up for 24 volt, and I'm going to leave this up so that our camera guy, when we're ready, can share the slide if we needed. So, because the other thing we're going to cover too is when you got 24 volt operation, how we set up the dip switches for blower airflow and how we measure the total static pressure, and talk more about that. So with that, JD, are you ready?
Yep.
All right, so let's jump into this equipment. So JD, refresh my memory here. Do we have this thing set up right now for 24 volt? Or do we have it set up for the GREE control?
So it is set up for 24 volts. To do that, we had to adjust the dip switch on the indoor unit, SA1. Dip switch number 1 has to be turned on.
Okay. And so SA1, just to refresh my memory, so SA1 was those are heating dip switches the way we always looked at it with?
Those are cooling.
Those are cooling dip switches.
Yes.
So in the previous FLEXX, we never adjusted the cooling dip switches. We only adjusted the heating dip switches.
Correct.
Right?
Yep.
And the same thing's going to happen here. I believe we're only setting the heating dip switches for airflow, but now we are going to use that other switch bank, which we didn't use in the 410A version, strictly for setting this thing up for whether we want RS485 operation using the GREE controller, or whether we want it to be 24 volt.
Right.
Correct? Okay. So for 24 volt, does that switch in there need to be on or off?
For 24 volts, the SA1 number 1 dip switch needs to be on.
Needs to be on. Okay.
Yep. And same thing for the outdoor
So
unit.
the outdoor unit, is that an SA1 dip switch as well? when you guys set this up, so it's actually pretty easy. So you said that's got to be on.
SA1, number 1 dip switch needs to be in the on position.
So the recap, okay. So for 24 volt SA1 dip switch, number 1 needs to be on.
Yep.
On both the outdoor unit and the indoor.
And the indoor, correct.
And then I'm assuming if we go to RS485, we have to have the dip switch number 1 on SA1 off on the air handler and off on the outdoor unit.
That is correct.
Okay, cool. So that's pretty easy to remember.
Yep.
So that's not that complicated. Now, factory shipped. As I said at the beginning of this broadcast, we're going to start including the controllers with them. Our first shipment did not include those controllers with it. So, but they also come factory set up for our RS485.
Correct.
So when you get this thing out of the box and you're going to hook it up with 24 volts, while you've got power off to the outdoor unit, while you got power off to the indoor unit, set SA1 dip switch to on, SA1 dip switch number 1 to on.
Yep.
You are good to go. Keep in mind, anytime you're adjusting dip switches, you have to do it with the power off.
You have to turn power off and wait for this display to shut off too.
Yeah, I'd like the DC bus to dissipate. And once we power it up, you'll see there's a red light in here, and we'll point it out later on. It's pretty vivid.
Yep.
So, and if you're not checking the DC bus, which you can check from right here, if Nick can kind of get a close-up on that where my finger's pointing. So guys, I'll tell you guys, for safety reasons, for multiple things that we talk about here, you can watch that light, and we did it yesterday. We powered it off, watched the DC bus. That light never went all the way out until we were like well below like 3 volts DC. Yep. But my concern with everybody here is, you know, these capacitors, you touch that capacitor and you're standing on wet grass, you're going to get it. Okay? So it's all about safety as far as I'm concerned. So when you're working on the FLEXX units, when you have easy access to that DC bus like that, before you start unplugging and plugging anything, before you get your hands in there, get your meter leads in there, make sure that DC bus voltage just come way down. You know, I would say if you probably get below 10 volts, you're probably, chances are you're not going to hurt anything.
All right, welcome back, everyone. I'm going to get to your live questions. Before I do that, I just want to remind everybody the Ask a Question button is on your right-hand side of the screen. Go ahead and get those questions into us. As I've said many times before, guys, these webinars and podcast or broadcast or whatever you want to call them, we do these for you guys to hopefully get you guys good information so you'll know what you're up against installing these products, especially with this being brand new R32. I think it's important that we get ahead of it so that when you guys start getting them, you're going to know exactly what to do with them. So by all means, type in your questions. We're more than happy to answer them. So with that, JD, you want to go ahead and give us that first question and we'll roll with that?
Yep. So the first question from Shreyas is, can we talk about matching up the outdoor unit with other manufacturers' air handlers? Anything new that we have to pay attention to versus the 410A FLEXX units?
That's a good question. So before I answer the question, we're going to refer back to the wiring diagram for the indoor-outdoor unit and a 24-volt thermostat. So we're going to show you here on the website. If you go to our website at greecomfort.com, if you go under resources, and then you go under system documentation, you click on that, you go to central air over on the left-hand side. It's hyperlinked that way for you. So then you can go to FLEXX R32, and the manual we're going to want to pull up is the indoor installation owner's manual. So we'll get that open up. And we're going to look at the wiring diagram, which I believe is around page 30 something. So let us get there. Go back the other way, I believe, a little bit. There it is. Okay. So obviously this shows your line voltage power and everything. I kind of talked about this in the video, but I want to readdress, the whole thing with R32 and it being that it is an A2L refrigerant, and the manufacturers are required to have an alarm that will shut the unit down if a leak detection is detected. And then we will cover this in the video later on, what happens after it goes into alarm. Once it goes into alarm, if the detection sensor is able, when it goes into alarm, it turns the blower on high speed, turns the outdoor unit off, or turns auxiliary heat off, which we're going to show you that in the video that it does work that way. And then you get an audible alarm, and an error code, if you're using GREE's controller, is produced on the, well, I think it's, JD, didn't it say something like refrigerant leak detection?
Yep, yep, the RS-85 485.
Yeah.
Yes.
So anyway, it says you got a leak, basically had a refrigerant leak. So whether the heat pump was running, electric heat, or both, it's going to cease operation of electric heat. It's going to cease operation of the compressor outside, turn the blower on high speed, and it'll remain that way until the sensor clears. Once the sensor clears, it will allow the heat pump to start back up, or it will allow the electric heat to come back on. So in this, and I know what you guys may be thinking, okay, what's this got to do with using another manufacturer's unit? Well, that's why I pulled up the wiring diagram here and kind of re-talk about, if you look at the thermostat, you got a Y connection from your thermostat that goes to Y on the indoor unit. And then from the indoor unit, Y1 goes to the outdoor unit, Y. Reason for that is there's a relay in that board. So once it goes into alarm, it breaks the connection between Y and Y1 and drops the compressor immediately. It also will energize that L terminal and send power to the L terminal on the outdoor unit to show the error code on the outdoor unit. I also talked about this in the video. The wiring diagram shows L from the indoor unit going to L on your thermostat. Again, I'm going to repeat this. Be very careful with that, because some thermostats, the L output is an output voltage, and some is an input voltage. If that's an output voltage, the outdoor unit or the indoor unit L terminal is also going to be an output voltage, and output to output usually means magic smoke. And you guys don't want the magic smoke. It means we fried something. So if you're not sure, just don't hook it up, because otherwise you're still going to shut down. You're still going to follow all the protocols for safety for A2L refrigerant alarm sensing. It's just the homeowner's not going to see it on the thermostat. And I don't know, because that L terminal, in my experience, in all the years that I've been doing tech support and from the field, the L terminal was just a light that lit up on the thermostat. But these newer digital thermostats, I don't know what it does to them. I'd have to read up on the manuals on different thermostats to say, okay, if the L terminal is powered, does it give me an error message? What does it say? I don't know. You'd have to go to that manufacturer's thermostat and manual and figure that out, right? So that's the biggest key. One of the reasons why you got to be really careful if you use a GREE unit, GREE outdoor unit with a third-party indoor air handler or coil or anything else. So, because if you've got to have that protocol in there by government regulation that shuts that unit down if the unit goes in alarm. And I don't know if the third-party manufacturer is going to do it the same way GREE is doing it here. The other thing you got to be mindful of is, as I said, I don't remember if I said it in that part of the video or not, but the new R32 air handler uses temperature sensors on the coil, both inlet and outlet. They are used in the RS-485 if you're using GREE's controller. They're really not looked at. In other words, it doesn't communicate it to the outdoor unit main board if you're using a 24-volt thermostat. It loses that capability because you don't have that comms anymore, okay? So with the indoor unit now, before with the 410A, we were using a TXV on the indoor coil. Now we're using the EEV. So I don't know if this third-party manufacturer is going to use a TXV or an EEV or what. So all I can tell you guys is this. GREE is really not promoting it to be matched with anybody else's unit. And obviously they're not going to test it to run it with anybody else's unit. So if you want to try it with a third-party air handler, you're kind of on your own. I would stick with a match system myself and use, if you're going to use a GREE outdoor unit, use a GREE indoor unit. So especially if you're talking dual fuel. GREE is coming out with an R32 dual fuel coil. We don't have them yet. They're ready. They're ready, but they're not ready. They're still waiting on some I don't know if it's ETL approvals or whatever they got to get, but I'm thinking by the end of second quarter, I believe is last I heard, is when we will probably have those available. So not very far off. We will have R32 dual fuel coils available to match with the new R32 FLEXX Ultra units, and also with the FLEXX Eco that's going to be R32 as well. So I hope that answers your question. You know, it's probably not what you wanted to hear, but I mean, I think it's the same thing that other manufacturers are kind of where they're at. You know, with this whole A2L alarm stuff, you got to be really, really careful matching it with other pieces of equipment. Do I think the unit would probably work okay with the TXV, provided we have the right protocols for the alarm? Probably. But again, it's nothing we tested. So, JD, you got anything you want to add to that? Or
No, I think you went in pretty good detail on that one. Yeah,
okay.
I would agree with you. You know, we don't know what the other manufacturers are doing, so ideally you want to, you know, match the systems that way it works how it's designed to.
Well, in a lot of localities and different states and stuff like that, you know, you have to use an AHRI match system to even get a permit for it to install it. So I don't know that we've got any AHR matches or any third-party units that are matching, you know, have an AHR rating to the GREE FLEXX condenser. So that may be a potential issue as well.
Yeah, not that I'm aware of.
All right, do we got any more questions?
Yeah, we got a couple more that came in. This one's from Joseph. He said 4 and 5 tons are they also good for 25 foot of line set for charge? And
yes,
yeah,
they are. I just failed to type that on that display that I showed.
Right.
I think I mentioned it in the video. Oh man, I forgot to put that on here. But yeah, so all of the units are good for 25 feet. The difference I was showing in there was between 2 and 3 ton, they have the same amount of charge per foot, and 4 and 5 ton has a different charge per foot after you exceed the 25 feet. But that also means if you put 10 feet of pipe on it, and I don't ever recommend less than a 10-foot line set. That is kind of the golden rule we go by with GREE. 10-foot minimum. You always need at least a 10-foot minimum refrigerant, whether it's a mini split or anything else, because you got to have some room in that piping between the indoor and outdoor unit for flow. And if you got these really short line sets, which I mean, I guess it's possible, you can have a condenser and an air handler right on the other side of the wall on the inside, but still, I would keep at least a 10-foot minimum on refrigerant piping. And then, but that doesn't mean you deduct anything for that extra 15 feet that you didn't use. They already incorporate that into it. The only thing you will do is add additional charge if you exceed 25 feet. You'll use those multipliers I mentioned in the video of how many ounces you put in per foot over 25 feet.
Yep. And in the 410A unit, just a reminder too, they were pre-charged in the matching system for 31 foot, but that's because the indoor coil had valves and had refrigerant in it. So
that's another difference with the FLEXX R32. There is no service valves on the indoor units anymore. I actually like that because I think it's just a cleaner way to do the piping. with the service valves on the indoor units, you had to come out to the right because your flare is pointed to the right. So no matter how you do it, you were going to have piping blocking your door access into that coil. With these new flares, with the flares sticking straight out, now I can come in with my pipe and I can easily go up, down, right, left, and still leave me clearance that if I need to get into that coil, be able to get the service panels off and get into the coil. So I think that's a huge improvement by GREE by doing that. So
Good point. I didn't even think of that one.
and also if you're good at doing flares, and by now we should be, right? And we should be using the proper tools, flaring gauge, making sure we're making our flares correctly, make sure we're using a torque wrench and we're torquing it. You know, these things do require 3/8, 3/4 piping. So if you're doing a 4 and 5 ton unit, you're probably going to have a 7/8 pipe, which we highly recommend you replace. But realistically, if you can, use a tubing bender and get good at using a tubing bender, not all applications, but you ought to be able to, on most of your installs, run all new refrigerant piping and use a good tubing bender and never have to put a torch on it. You got 2 flares inside, 2 flares outside. Your torches can stay in the truck, which I like that. It's just less chances of having any kind of contamination in your line set, whether we were flowing nitrogen while we're brazing or not. We just have, if we don't have to put a torch to the line set at all, that's even better. So anyway, all right, what else we got?
Let's see here. Hold on, I lost my screen here. There it is. All right, so next question. Is the FLEXX system going to stay multi-tonnage? I guess we're referring to how the 410A FLEXX had dip switches on there to switch to tonnage, where now the R32 FLEXX, there's not going to be an adjustment on there. They're actually just going to be a 2, 3, 4, and 5 ton unit.
Well, see, I'm getting mixed. I've been getting mixed answers about that. I think it is a good possibility they will be going to a 2, 3 ton and a 4, 5 ton. But as of right now, the equipment that we got coming in, or that we have, is 2 ton, 3 ton, 4 ton, and 5 ton. So I'm going to go with right now. That's what we have, but it may actually change, and we'll have dual tonnage with the machines. Okay.
All right. And let's see. Next question, Rain. You wanted us to repeat that phone number for tech support. So phone number is 888-850-7928. Again, 888-850-7928. All right, we're putting that on the screen for you too.
Okay.
All right, next question from Lee. Will the GREE controller do other codes or other air codes?
So as I said, I believe we said in the video, I don't remember, or it's coming up in the video. The controller we had was one that that GREE just handed us when one of our guys was visiting the factory. I don't know if that's the actual production controller that's going to be used with the R32 FLEXX. But we do know it gave us the code about the refrigerant leak detection, which you'll see in the next video part that's coming up. But I do believe it is capable of giving you a display of air codes on the indoor units, but don't quote me on that. Again, the controller that we had down in the lab, I'm not for sure if that's going to be the one that we're actually going to be stocking, and also is going to be coming with the unit. So again, R32 refrigerant equipment is new. This is the first landing of R32 FLEXX that we have. So we're learning and trying to pass on information with you guys as fast as it comes available and we're knowledgeable to it. Sometimes we're told things and we find out later on that it's not necessarily true. That's part of the reason why we go to the Atlanta lab and run the equipment and see it for ourselves and make sure we're giving you proper information. But I can't imagine GREE not displaying the error codes on those indoor controllers. JD, do you remember, did we produce any other error codes when they showed up on the controller?
Yes, and the E6 did show up when we were messing around with the wiring, just trying to see.
Which also tells me it's capable of giving me other codes. And you're right,
Yeah.
because if you don't have the dip switches set correctly and you're trying to use the RS485 GREE controller, if it's set for 24 volt, you're going to get an E6 error code.
Or CO. It was going back and forth between
Right.
E6 or CO, which is communication error.
So I think it's going to be capable of giving us our error codes. But again, guys, I don't want to really, put my hat on that yet until I see it for myself. So, anyway, we will more come on that as well, guys. We're not done with what we're doing with R32 down at the lab and getting you guys information. So, as we get the production controller, we'll get it down to the lab, we'll get it hooked up, and we'll run it through its paces. We should have a copy of the installation instructions at that time, which should tell us a whole lot more about that controller once we got them landed here in the States.
All right. So next question, this is from Joseph. Let's see here. Guess he's wanting do we even have an R32 just standalone coil for the FLEXX unit, Greg?
It's coming.
Okay. Because he's wanting to use one, but he's wondering, if it came with a single speed blower fan or kind of what options we had there.
We have the air handlers.
Yeah, the air handler comes with a coil and a five-speed fan motor, but we don't have the R.
Talking a standalone coil, it's not going to have a fan in it. I'm
right. Yeah.
Not quite understanding here.
Yeah, it's kind of a confusing question, but
okay.
So I think to answer his question, no, we don't have a standalone coil yet, but they're in the
probably
process.
By the end of fourth quarter, or not fourth quarter, the end of second quarter, more than likely we will have the R32 FLEXX coils.
Otherwise, it's just a.
As of right now, all we have is the air handler.
Yep.
So, but
we
are still going to be able to do dual fuel, and we are going to have an R32 FLEXX coil that'll have the sensor on it and everything else, and the protocols for that to do it. So we will absolutely be able to do just like we did with 410A and being able to do dual fuel with the FLEXX. You will be able to do that with R32 as well.
Yep. All right. Next question from Ryan. All right. Is there going to be a wall hanger for the GREE FLEXX?
So he's talking about a wall mount bracket, I'm assuming.
Yep, that's what I'm thinking too.
So my answer to that is we don't sell brackets. Those are third party. So yes, as long as you've got a third party supplier that can supply you with a rack that it can handle the weight and have the right bolt pattern for that FLEXX, there's no reason why you can't put it on a bracket.
Don't we normally recommend like Diversitech?
We don't recommend anybody. You can use any third party wall mount that's going to hold that unit, hold the weight of that unit, and be able to structurally mount it to the structure. So I don't want to call out any one brand name over another because I mean, we don't sell it. So I don't.
Yep.
It's kind of like the tools, guys. We share tools in the videos and stuff that we use. We're not really promoting one over the other. I'm not going to get into that argument. I'm not going to get into that. Not even really an argument, that discussion, because you got one contractor that swears by this particular brand of tool, and you have another contractor says that's a piece of junk and he wants this tool.
Exactly.
We support the equipment. You choose your tools. That's my answer to that. You choose.
Yep.
You choose the supplier that wants to supply you with refrigerant lines and condensate piping and thermostat wire and all of that. That is a contractor choice. And I'm not here to beat up anybody about what they choose to use.
Yep. Good point. Good point. Next question from Shreyas. I think we kind of talked about this one earlier. He said, the distributors telling them we're going to be able to have dip switch configurations on capacity And instead, there would be just a 24. Well, I guess the stripper is telling me you have a 24, 30, 36, etc. But there's only 24, 36, 48, and 60K units on this.
As
right?
of right now, I believe
Yes.
we're going to have a ton and a half. But again, not yet. And it is a very good possibility they will go back to doing a 2-3 ton and a 4 or 5 ton. I like I said, I'm getting mixed answers about that right now. So I don't really want to say for sure either way which way it's going yet. So more to come.
Okay. Looks like one more question from Eric. Does the controller show operational data? I know the one that we had did, but I'm not, that's not the RS485, is it, Greg? Yeah.
It is an RS485 controller. Whether or not it's going to be the one that comes with the GREE FLEXX or not, I don't know.
Right.
And I don't want to speak to that until I have one in hand.
Yep.
And I just checked on it right before the show. I haven't got an answer yet as to whether or not we got those coming yet or where we're at with all that. I do know the next landed equipment that comes, this R32 FLEXX Ultra, as I said in the video, will be shipping with the unit. So right now on the equipment that we have, it's coming with no controller. That's why it's very important you know how to set up that thing for 24 volt. We will be getting controllers in stock that you'll be able to order and go to a GREE controller if you choose to. And then, like I said, then once the equipment starts rolling in that the controllers are included with it, then you're going to start seeing when you unbox a brand new unit, you're going to find the controller shipped with the air hand.
All right.
Again, it doesn't mean you have to use it. You can go with the 24 volt. And then
Right.
I still want to go. I'll give you one other thing that I'm looking at doing, because once I have that controller and I'm confident with it, so one of my next trips down to Atlanta, when I do this, I want to see if I can't do the 24 volt thermostat and the GREE controller and have them both hooked up. But one is your primary and one's your secondary. That may be very beneficial to you guys, because even if the homeowner doesn't want the GREE controller, they want their Ecobee thermostat or whatever brand they want. Maybe it's the I can't think. Anyway, whatever brand they want in their on their living room wall or hallway wall or whatever, they don't want that GREE controller on there. That's their choice, but it still may be beneficial that we can have the GREE controller on there hooked up as well for diagnostic information, where it gives you, air codes and temperatures and stuff like that. As long as it's not going to be the one sensing the temperature, then you can have that installed where the air handler is. So when you come to service it, you've got a control right there that's going to help you with diagnostic information. That's my hope. But again, more to come on that once I actually have a factory controller. Okay. So,
Yep.
And then also I do know for a fact that we have, a service tool coming. So, but we don't have those yet. So you'll be able to plug up to that unit and have a service tool and be able to see all the parameters and everything, which is going to be very beneficial as well. So, all right, JD, with that, we still got a pretty good amount of video here. So we're going to roll. We can follow back up with questions at the end here. So let's go ahead and roll through with the next video, and then we will come back to questions.
So what's our dip switch settings right now for airflow for heating the SA2 dip switches?
1 is off, 2 is on, 3 and 4 are off on the SA2. The bottom one's SA2, really hard to read, and the top one is SA1. SA1 is all on. Of course, that's the number 1 dip switch is what we turn on to make it 24 volts.
So now I'm going to reiterate what JD was just saying, okay? Because I wrote it down. He said the number 1 switch on SA2 is off, which is what 1 means. 1 means off, O means on, okay? And then he said 2 was on. 3 and 4 were off. So that's the factory default, level default setting for the 3-ton air handler, okay? We got the MagnaHelic gauge set up. Let's see what kind of static we're running. Maybe we can kind of...
So, as you can see, we are including the filter in this demonstration. That's why it's actually, we pulled it out and put it on the front.
Did you disconnect this?
No,
and zero it?
Yes.
Okay, cool. So now, one thing I want to mention to the audience is, guys, look, this is a lab unit. I don't have ductwork and everything on it. You know, when you're doing this out in the field, it's going to be completely different. But the importance of making sure you're verifying the static pressure. Now, let's talk about static pressure a minute, and then I'll go back to the static pressure charts in a minute. We'll talk some more about it. But even if you use the GREE controller, I told you guys you don't have to set the dip switch profile because it comes more of a variable speed operation. But keep in mind, you still got to make sure that this thing's not running against high static. An ECM blower pushing against high static is a motor killer. I don't care who makes it. You can't just expect an ECM motor to overcome high static.
Right.
So I kind of want to demonstrate what happens here. So we've got something kind of restricting our airflow on the top up here. We're only running a 0.1 total static. That's nothing.
Right.
So let's have a little fun.
Restrict that return.
So we jumped up to almost 0.2, right? Let's give it a little more. Now we're at 0.3, which is still not bad static, right? But again, I have no ductwork. I'm not pressurizing the system, right? I'm just trying to simulate here. So I'm choking it down. Basically what I'm saying is I'm choking the return way more than you'd ever be able to choke it if you had a completely ducted system, right? But it kind of gets the point across. So now look at my static. I'm up at 0.5. Now, you have a fixed torque motor. I chose level 3 as my airflow, okay? So let's kind of mark where we're at right now. So this is kind of a good demonstration. So I know where I'm at right here. I'm running a 0.48, that's fluctuating, 0.46, 0.48, up to 0.5, right around in there, okay? Right. I'm not gonna change anything other than, JD, let's lose the call.
All right.
And it'll take a minute for it to cycle off. Meanwhile, we're gonna go back to the shared screen again. I'm going to show you what we're going to be doing here. We got to wait for it to cycle off. We could probably even just kill power, but then we're going to reset the dip switches. We're going to give it a higher blower profile. Okay. So I'm actually kind of increasing the torque level of the motor. Right. So let's see what happens to the static pressure if we go to a higher fan speed setting. So in other words, in my opinion, I'm giving you kind of a crude example. I got 0.5 static. For residential, that's not bad, okay? But let's say that was 0.8. That's horrible. So, and I'm not moving enough air, okay? More than likely, we'll look at it on the blower chart. But if I increase the blower speed, I'm already not moving enough. I can't move the air. I can't move 3 tons of air in the existing ductwork. If I increase the blower speed, I don't know that that's going to help me, is what I'm getting at here. So let's prove the theory or disprove the theory. So we're going to go to the 3-ton fan performance data. We were at speed 3 at 0.5. Okay, that's only 1,000 CFM. So I'm moving 333 CFM per ton if I'm moving 1,000 CFM at a 0.5 total static, right?
Yep. That's a little below what we like to see.
It's a little low. I want to see at least 350. Go ahead and set them dip switches. You need 3-ton level 5, all off.
All right.
It takes a minute for that blower to get rocking and rolling.
Still ramping up.
So I don't know if you guys just heard that in, through my microphone or not. The one thing that's nice to know, the reversing valve is energized in heating mode on all GREE's equipment, okay? Even though the reversing valve is energized, and it's energized off of the thermostat OB terminal, you set that up to energize the reversing valve in heating mode, okay? So it stays energized the whole entire time that the thermostat's set to heat, okay? But that's the 24 volt signal, okay? GREE uses 230 volt reversing valves. So when you're using a 230 volt reversing valve, the board is actually controlling when that reversing valve is energized, okay? So, I don't know, like I said, I don't know if you heard that. What GREE actually does, even though it's in heat mode, and the machine knows it's in heat mode with a 24 volt call, it starts that unit up, runs for a minute, then it engages the reversing valve. That reversing valve is not energized the entire time. So it's not until you get a call, compressor actually starts running for a little bit, then it goes up. Well, now we got some static.
Yeah, we do.
So it's kind of, so that reiterates what I was saying. So back your damper off on the top a little bit. Don't take it off. Yeah, there you go. See if it drops any. And then back this off just a little bit. You got to give it a minute. You're still in inches of water column?
Need an average. There we go. I think that's it.
I can't see this other thing.
0.55 now. We'll slide it back.
Okay, drop your there we go. Again, I'm going to tell you guys, this just kind of gives you the concept behind it. When you don't have a ducted pressurized system, this is not the same world. It really isn't. When I set that blower profile on speed 4, or speed 5 is what we set it for, at 0.5 total static, I should be moving 1620 CFM. If you do that, if you start it out where you're at 0.5 static and you're set to speed 3 and you're only moving 1,000 CFM and you crank that thing all the way up to speed 5 and you're supposed to be going from 1,000 to 1,600, throwing an extra 600 CFM into ductwork that couldn't even move 1,000, you have no choice but that static pressure to go up. Even though the blower is thumping a little harder to try and overcome it, it's still not going to do it.
Right.
So, again, you know, my thought process to that, my explanation here is, do not assume that just changing the blower speed to a higher speed is going to force that unit to deliver the air that you need it to deliver. You have to do a static pressure measurement to verify that. All right, let's shut the system back down. SA1
dip switch number 1.
This dip switch number 1 needs to go to
the off
position. So let's go ahead and do that. And then also on the outdoor unit, right?
Yep. So on the outdoor unit, SA1 dip switch number 1, as you can see, is in the off position now. So that will set us up for the RS
485.
485.
Okay, I'm ready. If you're ready,
I'm ready.
Power that up. I'll power this up.
Here comes the blower. Blower just came on after the coil heated up.
I don't think it really delays because of the coil heating up, though, does it?
No, I don't believe so.
It's not on long enough. The unit's not running long enough for it to really heat up that coil.
It was warm coming out right away.
So maybe with RS485 it does delay a little bit.
Right.
It's not significant though. Because I seen with the 24 volt, it was pretty quick.
Yeah.
The blower come on, but it was going up slow as that machine's already grabbing, you know, speed and
Almost
stuff.
came on simultaneously, but it was slowly ramped up, where this came on almost right away.
The bottom gauge.
So we're going to be looking at our airflow here.
All right, so we can restrict it back and just see what it's doing. Well, that kicked it up right away, didn't it?
Yeah.
So it's acting more like variable speed.
It instantly kicked it up, yep.
Oh, wow. 0.7. 0.6. 0.75. She's bouncing. I don't like it seeing going that high. That's what I was talking about. Even if you're using a GREE controller, you get more variable speed operation, but you've got to make sure you're not running high static. That dropped it considerably.
Yep.
Now let's take it back away. I want to see if the blower seems like it's ramping down. Now again, the blower speed could also be dependent upon the demand. We only got a 2-degree demand though. But that's not high static. But we seen the blower actually ramped up when we slid that thing in front of it. I want to do it. I want to do it again, just to see. Worked better when it was flipped the other way.
It did.
That jumped it up. See, I don't like it going that high. Even though you see it around that 0.66, then it goes to 0.75, then it drops back down. The thing is though, you don't want to see it going up into that 0.75. My guess is that bouncing around so much could have a lot to do with turbulence too, because we don't really have a pressurized duct system, like I said, and we're putting the thing right on top of the blower. So it's not the same as doing it in the field. So, all right. I like it.
So you want to turn it on to aux heat now?
Yes.
Turn it to off, let it cycle off, and then turn it to aux heat.
Yeah, that'd be perfect.
Turn to auxiliary heat, and we're turning it up.
Yeah, and that fan came on right away. And there's your 25 volts. I do know it works when you go into auxiliary heating, you know, heat pump running. If we elapse that 35-minute delay, and then we have it at 2-degree differential, it will bring on aux heat. So we've proven that. You kind of focus in on this meter here. It's showing the 25 volts Let's see if it does it when it goes into alarm.
Instantly killed power.
That's what they told us. Now,
And as you can see, this displays refrigerant detection error.
Yep, and
the outdoor unit has a EA code.
now that audible alarm is extremely obnoxious, and it will go away once the sensor is cleared.
Question from Bradley. He's wondering if GREE is going to make an oil furnace or gas furnace so we can have a full GREE dual fuel setup.
They are going to be making a dual fuel coil for, and it's in development right now. The R32 dual fuel coil for FLEXX.
All right, next one is from Rocky. Can the system be used with zoning controls like Honeywell?
Okay, that's a good question.
So, you want me to answer that?
Sure.
So the answer is yes. The main thing we want to make sure is we're not exceeding, 0.5 static. We want to be sure to have a dump, not a bypass.
Well, I'm not against a bypass. I'll disagree with you there.
Okay.
And that's all. It's okay. Everybody has their own views. My thought process is I don't want a zone less than 50%.
Correct. Yeah.
And then you got to make sure you're getting proper bypass or a dump zone on this, in order for this, so the static pressure don't get too high across the system.
And when you install it, be sure to shut down each zone and check your static and make sure we're below below where we need to be.
I mean, they're already variable. It's a variable speed or variable inverter-driven variable speed unit, variable speed compressor is what I'm saying. Load demand matching, sort of, right? So it kind of takes zoning in a sense a little less important, right?
Right.
Because if you're already, heat pumps do a great job of maintaining temperature. They don't do a great job at high demand, okay? So if you're zoning, what you're doing is you're turning the temperature down in the zone you're not calling for, right? But then you're coming back and possibly putting a high demand on that. That's not ideal with an inverter-driven system, because now you're forcing that outdoor unit to want to ramp up to meet the level of demand, right?
Right.
When efficiency-wise, you'd be better off leaving that zone within a couple of degrees, right? And keep all the zones within a couple of degrees and let that heat pump maintain temperature at those lower revs. See what I'm saying? So, because the efficiency comes from the heat pump maintaining temperature at a low RPM of the compressor, okay? Low demand. That's why we want to set the temperature and leave it alone, let it get that low ramp and steady ride and try to maintain temperature like that, more so than we want to put demands on it where we're constantly causing the thing to ramp up. Because if you take even the FLEXX unit, if you take that unit and you're always giving it high demand and you're forcing that thing to ramp up full tilt all the time, you're not saving any money. You might as well put a 14-SEER unit in. Because that compressor is running at full bore trying to heat the house and catch up the temperature.
Right.
Okay? So that's where I say, to me, with an inverter-driven heat pump, zoning becomes less important. So I don't have a problem with you zoning it, but I don't want I would suggest, I'm not going to say I don't want, I would suggest that you not have more than a 50%, each zone being no less than 50%. And then also, don't be putting high demands on it. Right. Set those temperatures, so that the whole heat pump system is maintaining temp without huge demands. That's where the consumer ends up saving the most money.
Right. And the reason that I try to avoid a bypass is because we're putting that hot or cold air back right into that coil.
Yeah, but it mixes pretty well.
Okay.
I mean, okay.
That could cause the unit to ramp down.
In your theory, you're right if you were doing like a 25% zone and you're taking 75% and recirculating.
Right.
That's going to probably really cause you issues. If you keep it at 50%, that air is going to mix with return coming back, and it's probably not going to be as bad as you would think.
Okay.
That's why I was saying 50%.
I agree with that.
So, anyway, what other questions do we have?
Something else to keep in mind would be oil return too. Like, you know, if we have a high static because of a zone, it could trigger the oil return.
Well, we don't want the machine, as you well know, with the R32 FLEXX, it's got pressure transducers, so it knows what that indoor discharge temperature is. And if you're constantly making that coil in heating mode, running a high discharge temperature, you're causing the amp draw on the machine to be higher, and can actually, it's going to create other issues. And then if we go into cooling mode, that's even worse. So there you go with your oil return. What you're going to end up doing, even though we have forced oil returns with this machine, in other words, it has it built into the program where it goes into oil return, speeds the compressor way up to force oil back into the outdoor compressor. But if you're constantly running that indoor evaporator in low load conditions, then your oil is going to want to stay in the evaporator. So that's a good call, JD. I'm glad you brought that up.
Right.
Because it can cause oil return issues.
And that can take up to 5 minutes.
It's going to force excessive oil returns.
Yeah.
Well, but then again, in heating mode, if you're constantly running high discharge temperature, your evaporator is going to be sitting out there cold. We're not moving the refrigerant like we should, okay?
Right.
You're going to get excessive oil buildup in your outdoor evaporator as well. It's all, I don't know how to stress it enough, guys. Inverter-driven systems is all about airflow. And another way to prove that is if you look at AHR ratings, when you have non-ducted systems for inverter-driven equipment, your efficiency levels are much higher than ducted systems. A ducted system, you lose efficiency. Now, if we start messing with that airflow and don't have adequate airflow, and zoning is actually a component against that, you're forcing the machine to run at reduced airflow. You know, not system airflow because you're recirculating, your static pressure's not going too high, but you're still forcing the system to run at reduced airflow. Therefore, overall, you're reducing efficiency. There's a million different ways you can look at this.
Right.
So, anyway.
The EA code went away on this unit over here. It's staying on. And then as you can see up here, our GREE controller is still in refrigerant detection error. So we just hit a button here, that code goes away. That lets us know, you know, when the homeowner comes back home that we did have a leak. We did, you know, so they need to call a service tech. But you know, just pushed a button, that went away. We are actually calling for auxiliary heat. We're still in auxiliary heat mode. As you can see, we have 25 volts right here. So you know, it did what it was supposed to do. As soon as that sensor detected leak, it shut off 25 volts. The blower went to full speed. After it dissipated, the level dissipated enough for the sensor to reset. The unit, the 25 volts came back to the auxiliary heat, and all we had was the refrigerant leak detection on the controller. Just hit a button, you know, that took away the code, and now we can see our set point.
One thing I wanted to point out here on the outdoor unit was, I talked about this before, so that this was in that piping diagram that I showed you, where it showed the indoor board module cooling circuit or whatever. That's that liquid loop. In the piping diagram, that's what they're talking about, because this is what's cooling the inverter. This right here, just so you know, this is your power coming into it. Even though your power is over here, back behind here is the filter board. So you only have two boards in this machine. You have the filter board and you have the main board. So, and as far as getting into it, when I first looked at this machine, I thought, oh man, you got to pull a whole front panel off of this thing to be able to service it. So, JD, would you grab that panel? I want to kind of give them an idea. It's really not as hard as it looks.
So there's 3 little slots here. Just got to hold it out at a little bit of an angle. Slides right in.
You go up. There we go. Keeping all those tabs in was easy. Them sides was easy. There's one little hook up here you got to kind of fight, and you slap the top panel back on.
And just a few screws up top, a few screws along the bottom.
If, in my opinion, compared to the 4 and 5 ton, or not the 2 and 3 ton previous 410A Flex, this is much easier to get into and service and work on. Because the other one had, remember, you had the separate drive board back here, you had the communication board, you had the filter board, then you had the main board in the front. I mean, I can't even tell you, I've gotten phone calls from guys and they're like, I'm like, okay, did you check the drive board? What drive board? They didn't even know the motherboards were in there because they never pulled the side panel off.
Right.
So I kind of like this. It's a lot easier. Once they pull this panel off and pull this panel off, you can easily see every board in there. So, and from what I've understand, they've relocated the fusible plug, and it's in a different piping of the circuit, so we should see less failures on the fusible plug that we see. We didn't see a ton on the 410A model, but we did see some. And supposedly they went to a different supplier, from what I understand, with the fusible plug. So we should be seeing less failures with the fusible plug on the R32 equipment as well. So just kind of another FYI. So GREE does listen to us. So those are things that were brought up to them in future conversations or previous conversations we've had with them, and they do try to fix it. So.
All right, one more from Kenneth. Okay, if you ever have to change out the inverter board, how do you deal with that refrigerant circuit loop? Good question.
Oh, that's not as bad as it looks. Here, let's pull this back off.
Let's pop this door off.
Hold on. There you go. Swing it around.
Swing it around, just lift up, off.
So when you change this, and I don't want to do it because it's got all that thermal paste in there, it's messy, right? But if you undo these 3 screws, you can take this liquid line, and you probably gotta get that zip tie out of the way, but you'll be able to pull that liquid line back just a little bit. Gently pull it back, and then remember, when you change this board, you don't change the plastic. You're only going to get the board, but you can take the whole thing out, plastic and all, and then put it back, plastic and all. Okay, so if you take this cover off, pull that liquid tube back, undo all your plugs and everything else. As you can see, this kind of comes across the top. Cut that zip tie. Do your 4 screws for that. Do your 2 screws down there. You slide that whole thing up and out. Then what you'll want to do is take, like, we've even used like the automotive cleaning wipes. We've used like rubbing alcohol, something like that. You're going to want to wipe those tubes clean, because you're going to have a brand new channel. That channel is on the new board. You don't have to, the channel where, not the cover plate, but the channel where the tube sits into is part of the new board. You're not changing that, okay? So you're going to have a clean aluminum channel. So you're going to make sure you just wipe them tubes off to get any of that thermal paste that's on there off. They'll give you new thermal paste. You're going to want to put it in the channel before you slide the board in, push the liquid tube back, and then smear it on the front side of it, and then screw it all back in place, and you're good to go. And then just hook your wires and everything else back up. So I don't think it's going to be that difficult. I actually think it's a little trickier on the air-cooled inverters, because you have the pads on the back of it. You got to make sure that's all clean, because when it burns, you could get some solder pots in that paste. If you don't clean it off, you could have potential short.
Getting the screws all the way in.
Yep, getting the screws all the way in. I think this is going to be a whole lot better. So I think you guys will find that this will be a lot easier to change if you got to change the whole board. Like I said, guys, with GREE, we're always by your side.
All right, welcome back, everybody. I hope you enjoyed that broadcast. As you well can see that, JD and I both came from the field, and we're full of foo bars too, just like you guys. So we just want to show you that we don't always have our brains on either. So anyway, let's jump back into questions, JD.
All right. Next question is from earlier. Gary was asking, I think we kind of touched on this, but we'll go over it again. The new FLEXX R32 unit, will it work with a third-party R32A coil?
So that's very much just like the air handler. It all depends on the protocol for shutdown with an A2L sensor, whether or not it matches GREE stuff. And again, with the R32 Flex, GREE is using an EEV, not a TXV. Do I think it would work with a TXV? Probably. Do I know that for sure? No. So we can't just give you our blessing to say, yeah, it's going to work. You're welcome to try it if you want, but right now, my recommendation is going to use matched equipment. Use a GREE coil with a GREE outdoor unit or a GREE air handler with a GREE outdoor unit. The FLEXX R32 coils are coming. Hopefully we'll have them probably by the end of second quarter. So.
All right. Next question is from Eric. He's wondering when factory tours will be available. I'm not aware that GREE does factory tours. Again, that would be all the way in China, but I don't believe they offer them. Next question is from Matt. Said, what is the full operation mode if dehumidification terminal is energized during 24-volt control mode? And are we slowing the blower down? How is this different in the RS485 if used for control?
That's a great question, Matt. Thanks for asking it. So as far as the dehumidification terminal, as you can see from the wiring diagram here, we do have a DH terminal on the indoor unit. If your thermostat has a DH terminal and it's an output and you get a 24-volt signal to the DH terminal on the indoor unit, that's exactly what it's going to do, is it's going to slow the blower down. When on the RS485 GREE controller, I believe they're going to be doing that much like dry mode, like you'd see in the mini splits, where it slows the blower down to aid in dehumidification as well. Whether or not the GREE controller is going to have a thermostat in it to be able to measure humidity or not, I don't know yet. Again, I want to wait till I got that production controller that's coming with it. So hope that answers your question, Matt. Matt, it was a great question. I appreciate you asking it.
All right. Next question is from Tommy. Do we have to change our manifold gauges, vacuum pumps, or recovery equipment when dealing with R32 refrigerant?
That's another great question. As you probably seen from me setting the sensor off, we're going to call that a de minimis amount. But I had no other good way to actually just set off the sensor for you guys. So to show you what the system would do, we also need to make sure that it's doing what it's supposed to be doing so we don't run into any other issues, which we clearly showed you it does. So just keep in mind on the R32 refrigerant tanks, they are going to be reverse thread. So you are going to have an R32 charge hose or adapter. And then recovery tanks, you're going to have specific recovery tanks for R32 refrigerant as well. And I do believe they have reverse threads. As far as gauges go, the gauge connections on the FLEXX are no different than the 410A machine that we had before. They're no different than the mini splits. So you're not going to need any special connection hoses on the equipment itself. As far as your gauges go, a gauge is a gauge. Again, a good technician is going to troubleshoot by temperature, not by gauge pressure. So it's all about being able to get the temperature equivalent of like the indoor coil or the outdoor coil. So if your head pressure is whatever pressure, you want to be able to condense it to convert that to the condensing temperature. And if your evaporator pressure is, 125 pounds, what is that in temperature? That's what we really care about when we troubleshoot. So whether or not you want to purchase new gauges is completely up to you. My only recommendation is it is a good idea to have a new set of R32 gauges because it's going to have that pressure temperature conversion chart right on the gauge itself. So anyway, with that, and again, I talked about this before. If you're married, like I am, it gives you a good excuse to tell your wife you need to buy some more tools. That, you know, your old gauges just won't work. They don't know any better. So buy yourself a new set of gauges. As far as recovery machines go, yes, you have to have an A2L rated recovery machine because you are pulling refrigerant out that is considered mildly flammable. As far as vacuum pump goes, I can't imagine why you'd need a special rating to a vacuum pump because you're not supposed to have any refrigerant in there when you're pulling evacuation on a system. So I think that covers most of the tools he mentioned, didn't it, JD?
Yep. Yeah, vacuum pump, recovery equipment, and manifold gauges.
All right.
Yep.
Next question.
So one more question here from Carlos. During defrost, the fan should shut off, correct? Talked with technical support, and they mentioned to the D wire from the outdoor unit to the indoor unit. Customer called saying they still feel cold air. Should I do forced defrost to check the fan shut off, to check to see if the fan did shut off? The FLEXX is a FLEXX system with a conventional thermostat heat pump setup, nothing wired in aux/W2.
Okay. So I'm going to refer back to that wiring diagram again on our website so that we can talk about this and have a wiring diagram in front of us. Okay. So the way this works, if you look at the outdoor unit D terminal, that's going to the D terminal on the indoor unit. Then you also have your W2 auxiliary from the thermostat to the indoor unit. The way the system's supposed to work is if the heat pump is the only thing running and it goes into defrost, that means you are not going to have 24 volts on the W2 auxiliary on the indoor unit coming from your thermostat. So when D is energized on the indoor unit, the fan should shut down. If you do have 24 volts applied to the W2 auxiliary terminal from your thermostat, in other words, the heat pump is running in heat pump heating mode and auxiliary heat is running at the same time, the blower will not shut off. It will stay on. So that's the way it works. And again, keep in mind, guys, these things are not in defrost long. About 2 minutes. Because the one thing that the GREE FLEXX has the ability to do versus other heat pumps, when that thing goes into defrost, it is able to scream that compressor. Another reason why I make a point to tell contractors, don't put the heat pump right outside the master bedroom window because it's going to go into defrost in the middle of the night when the end user is trying to sleep, and that's when that machine is going to be at its noisiest, is when it's in defrost, just flat screaming so it can get the defrost cycle over with and get right back to heating. So be mindful of where you're installing that outdoor unit. All right.
Yeah, it looks like all the questions.
All right, so we'll hang on for just a minute longer in case you guys got any last minute questions you want to get in here. The tool thing I was just going to make mention to, if you go to our website and go under contractors and go under training, and then you go under videos under contractors. So let's go back to, go down. There we are. Right there, instructional videos. So you can get to some of our video links there. And I know Daniel and I'd have to play around there for a minute, but I know Daniel and I did do a previous broadcast about R32 refrigerant and gauges and tools and stuff that you're going to need going to R32. But it's been a while since we did that. So there's a video out there about different tools and stuff. JD, anything else that you wanted to add?
No, I think we pretty well covered everything.
So I thought part of the video that I really liked, and I liked the discussion that you and I had, was about zoning. You know, if you guys really want to zone, multi-pro is your friend, because multi-pro is the way to go with zoning rather than ductwork, because you're zoning by refrigerant and you're zoning by the indoor unit for that zone being able to communicate with the outdoor unit for that zone and be able to control our temperature in each zone by the speed of the compressor, the flow of the refrigerant, the temperature of the indoor coil, and the speed of that fan altogether. And as you've seen with my previous videos before, when we talk about inverter driven equipment that is fully communicating like that, it knows the indoor set point, it knows the indoor coil temperature, it knows the outdoor temperature, it knows the outdoor coil temperature, it knows how much demand's put on that system, and it's able to load match all that together so we get a nice steady run rate, and when needed ramp up higher, when not needed so much it ramps back down. The whole idea is to keep the machine on and get optimal efficiency out of it. So I still say multi-pro is the best way to go for zoning rather than using dampers and ductwork. Dampers and ductwork, as we just mentioned in that video, your efficiencies go down when you're using ductwork. So if you can minimize the ductwork, I'm not saying use no ductwork, but if you can minimize the ductwork, you also will improve the efficiency. So you can have a ducted unit as one of your zones, but you got minimal ductwork to that ducted unit. It's not like you're ducting an entire system. So anyway, there's other ways to zone in today's world better than using ductwork. So yeah, matter of fact, we even did a versus video on that. So if you can go out and take a look at our ductwork versus refrigerant piping, that was a pretty good video that Vanessa did for us, and talks about just that, where the advantages of zoning by refrigerant essentially versus ductwork. So any more last minute questions?
No, that's all it has been in there.
Okay, so like other broadcasts we've done before, I do want to point out to you guys that we will leave the Q&A open for just a little bit longer, even though we're going to shut down the broadcast. That's going to be open for a few minutes. Please, guys, give us the good, bad, and the ugly. So if you like what we're doing and just want to tell us that, that's great. If there's something you'd rather see us do, and is there something we could do better for you, please comment to that. Because, you know, if I don't know what you want, I can't do it for you. I try to come up with best content as we possibly can, along with JD's help. We try to give you guys what you need. So, but you guys may have other visions. You guys are out there in the field. You're out there in the trenches. You're doing the work. What can we do that might make your installation or your servicing a little easier in the future? What kind of broadcast video can we do to help you guys? So if you got ideas, by all means, shoot them to us. We'll try to, I can't promise you we'll accommodate, but we will try to accommodate. So, all right. All right, we'll leave that open for about 5 minutes after we end the video here. And anyway, I hope you guys all have a great day. Hope you're not freezing out there. And again, at GREE, we're always by your side.
By your side.